Hi everybody. My name is Jingshen Wu. Today I'm going to walk you through the Abalone Age Prediction project. This is a regression problem where we predict the age of abalones based on their physical measurements. I will explain the key steps, the model we used, and what the results mean. Let's get started. The first step is the understanding the data sets. So firstly, let's talk about the data sets. It include things like the physical measurements, including the length, diameter, height, and the weight measurements, like the whole weight, shaft weight, and more. And the categorical feature, including the sex, like the male, female, or infant. And the last one, the target variable. Uh, Include the rings, which tell us the uploader's age. And our goal is to predict the number of the rings, which is a continuous value. So this is a regression problem. And step two is the data pre-processing. Pre-processing. Before we can build a model, we need to clean and prepare the data. Here's what we did right here. The first one is the handling the missing values. Luckily, there were no missing values in the dataset, so we didn't have to worry about this step. The second one is the encoding categorical variables. The sixth column is the categorical, so we used one hot encoding to turn it into the binary columns like the male, female, and so on. What's more, the feature scouting. We scout the numerical, the features using the standardization. This is important because the features like the weight and length are on the different scales, and scaling ensures not single feature dominate the model. And the last one is the train test speed. We split the data into the training and the testing sets. Like the 80% training and 20% testing. This let us to test the model on unseen data. And the next step is the modeling. We used totally two models for this project, the multiple linear regression and the random forest regressor. So let's start to talk about why these models are good fit. The first one, the multiple linear regression. This is a simple and interpretable model that assumes a straight line relationship between the features and the target. And it also a good starting point, but it might not capture more complex patterns in the data. And the random the forest regressor, this is a more powerful model that combines multiple decision trees. It's great for this data set because it can handle the nonlinear relationships, and it's robust to outliers and works well with the both categorical and the numerical features. It also gives us the feature importance, which tell us which features matter most for predicting the target. And the step four is the validation and evaluation. To evaluate the models, we used the first one is the k-fold cross validation. This splits the data into the k subsets and train the model k times, each time they're using a different subset for validation. And it also helps make sure the model's performance is consistent and reduces overfitting. The second one is the MSE. It also called the mean squared error. This measures how close the prediction are to the actual values. Lower MSE means the better performance. Yeah, move to the next, the fifth step. It is the results and the insights. Here's what we found in this the project. The first one, the multiple linear regression, it did okay, but the MSE was the higher, especially to the test set. This suggests the relationship between the features and the target isn't the perfectly linear. The second one, the random forest regressor, this model performed much better with a lower MSE on both the training and the test sets. It also able to capture the more complex patterns in the data. Mm, The third one is the feature importance. The random forest model showed that the shell weight and the diameter were the most important feature for predicting the age. This makes the sense because these are directly related to the abalone's growth. Move to the next is the bias and to variance the trade-off. Let's talk about this one for the multiple linear regression. This model has the high bias because it assumes the simple linear relationship, which might oversimplify the data. But it has the low variance, meaning it's the less likely to overfit. And for the random forest regressor, this model has low bias because it can capture complex relationships, but it has the higher variance, meaning it's more prone to overfitting if not turned properly. To handle this, we used cross validation and uh, hyperparameter tuning to make sure the random forest model generalized well to the new data. And the last one is the real world implications. The results from this project have some real world applications. The first one is the fisheries the management. Accurately predicting the abalone age can help manage the fishes and ensure this sustainable harvesting. And for the future importance, knowing which the features matter most, like the shell weight, can help the biologists focus on the specific measurements when study abalone growth. And model selection, the better performance of the random forest model showed that the more complex models might be needed for the accurate predictions in real-world scenarios. And all in all, to wrap up, this project walked us through the steps of the pre-processing, the modeling, and evaluating a regression problem. The random forest model outperformed the multiple linear regressions, showing the importance of the choosing the right model for the data. The insights from this analysis can be applied to the real-world problems like the sustainable fisheries management. So yeah, thanks for watching. That's all. Thank you.